the number of people that you have in your analyses, right? No missing cases. This is good. We didn't exclude anybody, so things are looking good here. Dependent variable encoding, okay? Judah, what is this telling us here?
Life is 0 and death is perfect.
Right. Which one is our reference group?
0. Life.
0, life, right? And so this is good. You want to make sure you don't switch this around or you got the wrong coding or something like that, and you're like, oh, depravity, or the more depraved your crime is, the less likely you'll get executed, because sort of switch this around and I'm interpreting this backwards, right? Making sure that you know sort of which variable is which, right? Same thing here, so you got categorical variables, and it's going to tell you how these are coded. Here, VIS delivery, 0s across the board, right? For indicator variables 1, 2, and 3. What's my indicator variable for 1 testing, Trent? My first one. What's my first indicator variable giving me?
That's just telling you that since the people that did not have any VISs, that because there weren't any, that they weren't private, Q&A, or open.
Right. So we've got...
Oh, the number 1 is telling you which that's private?
Yeah, exactly, right? So our first indicator variable, and when we get to our coefficients table, we're going to have an omnibus test for VIS delivery, and then it's going to go down through and it's going to give us specific contrasts.
Mm-hmm.
This is saying our first specific contrast in there, and SPSS is going to label this as 1. This refers to private versus none. Number 2 is Q&A versus none.
Mm-hmm.
3 is open versus none,
Mm-hmm.
right? And so this is important that you know that this makes sense to you, that this is how you want it to be coded, because if we would have gone through and not changed that default, which one of these would have been our reference group? Open would have been the reference group, right? And had you not going through and taking a look at each part of your output, you might have missed that and started interpreting things as your none as your reference group, when that's actually not what it's saying. You've got a completely different thing going on, right? So with these models, always know and make sure you're 100% solid on what your reference group is here, okay? And then we've got our beginning block. This is telling us for having no variables in the model. No variables in the model, not having any predictors in here, how do we go through and make a prediction on whether or not people are receiving death penalty or life in prison, right? And so Candace, what's going on here? What's this model doing in the absence of predictors? What is it doing?
Which model?
This model that we've done. So in the absence of predictors, if we don't have any predictors, what's the model predicting in terms of whether or not people are getting life in prison or getting the death sentence?
It's predicting whether they're getting life or death sentence based on
no predictors. And who's it saying gets who's it predicting gets life or death, and who's it predicting getting life?
It's saying everyone gets the death.
Yeah, it's saying everyone gets the death penalty, right? So basically, this model, in the absence of predictors, is just saying
Everyone's dead.
everyone's dead. Everyone's dead, off with their heads, right?
Kill them all and let God sort it out.
Why is it doing this?
Because our reference group is life and it was 0.
Okay, not quite. So, not because it doesn't have anything to do with the reference group. Why does this model, in the absence of predictors, just predict that everybody's going to get the death penalty?
because everyone dies.
It's an existential program. It's going to happen eventually.
Is it because you just don't
That's
have
the
anything
constant?
to predict with? Like
So it's
Yeah.
the lack of having something to use to predict an outcome just makes it go.
Oh, I didn't know. Well, no, it's more systematic than that.
Oh.
What? Go ahead, say it. You're probably right.
No?
Yeah.
Say it.
What were you going to say?
So just
Say something. You were going to say it. And it's right. What are you thinking?
I don't know. It's got something to do with the constant. I was thinking of something.
Yeah, it does have something to do with the constant.
But that's as far as I got.
It's holding the life as the constant, and therefore it's saying that it's.
Why didn't it predict that everybody would get a life sentence instead of a death sentence?
Because life is coded as 0?
No. Could a model without predictors have predicted everybody gets a life sentence instead of death sentence?
No?
Could. Not for these data. What's a more common outcome in these data?
Death.
Death, right? So in the absence of any predictors, my best strategy is just to predict the most common outcome, right? And so as long as it's like, in the absence of any other information, I'm just going to go ahead and predict everybody gets the death penalty.
It's just like predicting the mean.
Yeah, exactly, right? And so in the absence of any predictors, models is just going to say, well, we've got 52 people who got life sentences, 71 who got death sentences, but I'm going to go ahead and just predict everybody gets death, and I'm actually right close to 60% of the time just based on these data,
Because
right?
the data has more death than life, okay.
Right? But
So if the data had more life than death, then it would predict everyone to be in the life sentence?
yep,
Okay.
absolutely, right? And so all this is doing in the absence of any other information, your best guess is just to predict whatever the modal outcome is, and then just go with that, right? And so, and again, reasonable guess given no other information. And that's good, I hadn't thought about that, but it is just like predicting the mean, right? Like, I don't know, sort of whatever the mean is, that's what we'll guess. We're going to be wrong a lot, but we're going to be less wrong than if I would have guessed any other value.
Right.
So that's what we've got there, and want to take a good look there, because sometimes, so what happens if I'm trying to predict a very, very low base rate event,
That's good.
Not predict this.
right? And so if I go through and I take a look at variables in my equation here, right? What I've got is my coefficient, the standard error of my coefficient, and then my WALD, right? If I take the square of that and the square of divided by the square of that, I get my WALD statistic. I get my statistical significance, and then my exponent here, right? But for my just my constant only model, I'm not getting a statistically reliable effect. What does that mean? So I just interpret my constant in and of itself, right? Do I interpret this coefficient here? No, because that's a log odds, right? No one cares about that log odds. It's tough to interpret. But I can go through, and this is where SPSS exponentiates that, right? If we take base e to the 0.311 power, I get 1.365, right? And this would technically be telling me that the odds of death versus not death, or the odds of life versus not, the odds of getting a death penalty are 1.37 times that of getting a life sentence, right? Or alternatively, I could say the probability of receiving death sentence is about or the likelihood of receiving not a probability. So we're not talking about probabilities, we're talking about odds. So erase probability out of your language in terms of these interpretations, right? The likelihood of receiving death sentence is close to 40% more likely than receiving a life sentence based on this intercept-only model. Okay, but we don't have a statistically significant relationship here. So what does that? And this is not something you would normally interpret, but what would be our literal interpretation of that constant if we say that's not statistically reliable? What do you think, Trent?
I was hoping the look I was giving you was that I didn't know.
I know, that's probably, but everybody else is avoiding eye contact. You sort of happen to be in my direct line of vision there.
So the odds of getting it.
Is it just that there isn't an odds? It's kind of
Right.
down the middle?
It's not.
Okay, not that there's not an odds,
It's
right?
not different
Well,
from
you can't
zero.
rely that
You can't rely on
that
it.
there will be again. I mean, this
Right.
could just be.
Okay, so yeah, you're close. So it's not that there's not an odds,
It's the same
but it's not
as getting-
zero,
So
Right.
it's
because
50-50.
It's the
which
same as
is
getting
results in an odds of.
a life sentence?
If
Equally
it's
like-
50-50, what's my odds ratio if it's 50-50?
1 to 1.
One, right? And so this is just saying that it's not reliably different than even money based on this, right?
So you would interpret it as it's not reliably different from 1?
As it makes sort of there's sort of no difference in the odds of receiving a life sentence versus a death sentence, which makes some sense. I mean, you've got like 50. We've got more people in the sample who have who've been assigned a death sentence than a life sentence, but not by much, right? And this would say that sort of we don't have enough evidence to say that there's sort of a reliable sort of increase in the odds of death versus life based on just these data in and of themselves. Okay. All right. People kind of see what's going on here with this.
Yeah.
Okay. So this variable is not in the equation business. Hold off on that. This is your score test. These are your Lagrange multipliers. This is the intermediate test of your variables. We're probably not going to worry about that. But that's what that is. We'll go back to that and take a look at this in a moment. Okay. Then you get down to so again, just want to make sure people are starting to get comfortable with interpreting their odds ratio. Now, this isn't statistically reliable, right? But we're going to say the log odds of this constant are 0.311. That doesn't mean necessarily anything, but when we exponentiate this out, saying that the odds of death are 1.4 times greater than that of life, right? Or we could say it's about 40% more likely to be sentenced to death versus life in prison, right? But our inferential tests indicate that this isn't different than even money, right? And so we probably wouldn't put too much of an emphasis on this. Okay. Oh yeah, I can do that. That's cool. Okay. So what we're going to do, variable is not in the equation. Okay. So what SPSS does is it first estimates a baseline model, right? And your baseline model is your model with no predictors in. And so then what we do is we go through and we test a model with all your predictors, right? And depending on it, you can go through and do stepwise stuff and play around with this if you'd like. But here we entered all of our predictors in there simultaneously, and we have an omnibus test of our model coefficients. Anybody have an idea about what this test is doing? Or what the equivalent would be in a multiple regression?
I'm assuming the equivalent would be just like omnibus F of the multiple regression.
What's that?
I'm assuming it would just be the omnibus F.
Yeah, absolutely. This is just like your omnibus F, right? This is just a test of your overall model, right? Basically, this is saying, does my model with all my predictors, does it do better than a model with no predictors? Does my model with all my predictors, does it do better than just guessing guessing the modal response? Okay. And so we've got a chi-square test with 5 degrees of freedom, which is statistically significant, right? And so we're going to interpret and say, yes, it looks like our model that has all of our predictors is a better model than a model with no predictors, right? So we're doing better than just guessing the average.
Which
right?
is better, so it's saying, is the model with all the predictors better than the model with no predictors, which is the same as the model with, which is the same as the constant model?
Yep, just the constant
Okay.
model. Yep, absolutely. And so we've got a chi-square value of 21.1. Where are we getting this value? Right, so we're just testing this on a chi-square distribution with 5 degrees of freedom. How did we get this value of 21.05? Look at the table below it and see if that gives you any thoughts or clues.
Oh, it's similar to the naval Nagel cookie R squared. Well, if you round.
Okay,
move the decimal
that's
place
coincidence,
over.
that's coincidence,
Oh,
don't worry about
okay.
that. What's the other value in there that we spent a lot of time talking about?
The 2 log likelihood.
Negative 2 log likelihood, right? And what does negative 2 log likelihood tell us? In general, what is it an indicator of?
It's like, kind of like your F squared change.
Okay, good, you're on the right track. Kind of like an F squared change, right?
Broad view of our model.
Okay, model fit, okay. And so again, what we're doing is this is our overall test of our model fit. Do we want lower log likelihoods, smaller log likelihoods, or larger ones?
Smaller.
Smaller, okay. And so if we've got two models, if SPSS first estimated a constant-only model, and then it estimated a model with all of our predictors, and we're saying that the model with all of our predictors is better than the model that had no predictors, and our test statistic for this is a chi-square with 5 degrees of freedom, and that's statistically reliable. What did SPSS do to calculate that chi-square statistic?
Subtracted?
Yeah, subtracted what from what?
Two log likelihood without the predictors?
Absolutely, excellent work, right? What SPSS did in its test of your overall model is it calculated a log likelihood of the model with no predictors, right? And then it went through and it calculated your negative 2 log likelihood for your model with all of your predictors, right? And then so this is a model, this is your log it didn't give you the log likelihood of the model with no predictors, right? But then all it did is it took the log likelihood of your model with no predictors, and it subtracted from that the log likelihood of the model with all your predictors in there, and then took the difference of that, right? And the difference between that is the number of predictors that you have, right? So we've got depravity, we've got number of EIS statements, right? And then we've got 3 indicator variables, which gives us our 5 predictors, right? So it's testing a model with no predictors versus a model with 5 predictors, hence your 5 degrees of freedom. This is a chi-square difference right there, and a chi-square difference, a chi-square with a test statistic of 21.05 with 5 degrees of freedom, statistically reliable at p equal 0.001. Okay.
Sorry, I was trying to write and listen. So you're saying that the reported negative 2 log likelihood in the model summary section here
Mm-hmm.
is the log likelihood of a model with no predictors minus the log likelihood of a model with all predictors, and that's what that is.
No, close. What is this?
That's with all
That's
predictors.
with all
That's your log
predictors.
likelihood with all your predictors.
Oh.
What's the difference?
The chi-square?
The chi-square is your difference, right?
Okay.
And it didn't give us that number.
It doesn't give us the other number, but you could figure it out
Right.
on account of addition, right? Right? And you can get that.
That's faith in me
Right?
that I don't have right now.
So again, so this is your negative 2 log likelihood difference, right? And this is this idea of nested models, because your model with just your constant only is nested within your larger model where you've got all your predictors, right? And so your model with no predictors isn't very good. This is a substantial increase in your overall predictability of the model, and so what we would conclude based on sort of this omnibus test of our model coefficients.
So since the model with no predictors is giving us a what's it, expected of 1, then basically it differs significantly from being a ratio of 1 to 1.
Okay. kind of, you're circling the.
I know the
field.
wording's terrible.
No, and essentially what it's saying, the same thing as it's telling us with our overall omnibus app test and the multiple regression, right? It's saying our best linear combination of impact, depravity, and delivery